All right, and then our next example for a gas law is Charles' law. So this law is talking about volume and how it's affected by temperature as well. So volume and temperature, you divide them this time to get a constant value. So V divided by T gives me a constant value. So that means if T gets bigger, then the volume would also have to get bigger, right? Both things have to either be getting bigger or both things have to get smaller because you divide them to get a constant value, right? Again, just like last time, this does make them proportional, but these things are directly proportional. Which again is an ACT type question. So definitely for your science portion, they might have you look at data, look at a graph, and figure out if things are inversely or directly proportional. Right, this time I have volume and temperature that I'm looking at, that I'm comparing. So I can start wherever I want, somewhere in the middle here. And all I need to know is that as one increases, so does the other. So I'm going to end up seeing as this increases, so does temperature, and if volume decreased, temperature would also decrease, right? Is you'll end up seeing data that can recognizably fit a linear function, right? Now I didn't do a great job of drawing a line through my data there, but you guys can see what I meant. Right, this is linear. I'm going to have a positive slope, right? So as rise over run, it's going to be positive and positive, or negative and negative, depending on how you did it, because they could both decrease, right? But anytime you see a graph that looks like that, that should clue you in right away. Those things are directly proportional. As one thing gets bigger, the other one also does, right? And vice versa. So if you see those things in an equation, they should be on different levels of that equation, one on top, one on the bottom in a fraction, right? Or they could be on the opposite sides of an equation, like when you have like force equals mass times an acceleration, right? Acceleration and force are directly proportional. As one gets bigger, so does the other. But if you put them on the same side of the equation, mass is a force divided by the acceleration, right? So volume and temperature on the same side, they're directly proportional. Volume divided by temperature is going to be equal to another volume divided by a temperature for our gas laws. So we just have problems that look kind of like this. So again, worksheet I gave you, and I was just doing this and I realized I forgot to give it to the regular class. Just gave it to all the 1-act kids, but we'll figure it out. You can just do these examples in your notes. It's not a big deal. But it was that worksheet that I labeled number 1, right? And number 2 on number 1 is a Charles' law question. So it says if a basketball fully inflated holds 5 liters of air at 86 degrees Fahrenheit, what would be the volume of said basketball at 14 degrees Fahrenheit? Now we've all had this happen before. Right? I can't be the only one who's tried to play with a basketball in the wintertime and found out, it doesn't bounce, right? So it didn't lose any air, but at colder temperatures, the volume of the air tends to shrink, right? So we want to know how much did it shrink in this problem. So I started with a 5-liter volume. Again, it may or may not have said that that was a volume, but you should know liter is a volume unit, right? And it said that at my temperature for T1, since this is V1, is going to be 86 degrees Fahrenheit. My second volume is what I'm trying to figure out. I don't know that yet. But my new temperature was 14 degrees, kind of like it was today outside, or is currently. So 14 degrees from 86 degrees. Next thing we need to understand about a Charles' law problem is down below, pressure and amount of gas have to be constant. I can't have those other things be changing. But I also have a note there that says the temperature has to be in Kelvin, right? So we've discussed this before actually, why Kelvin exists to begin with. is because there's no such thing as a negative. And we already talked about that. Volume and pressure cannot be negative. If you are multiplying and dividing and you have a negative temperature, you're going to end up with negative answers that can't possibly exist. So Kelvin exists for a reason, right? Absolute zero, the coldest it can possibly get is zero. So I can't go outside of this quadrant that I have drawn up here in this graph, right? Negative temperatures do not exist, nor do negative volumes. So I just stay up in that upper right-hand portion of that graph. But that also leads to a problem out here. I can't use Fahrenheit because there are negative numbers for Fahrenheit. I have to do conversions, right? So again, I told you before, pressures and volumes, doesn't really matter what you use as long as they match. It does matter for temperature. You have to convert it first. So my first thing I'm going to have to do is figure out how to do that. So I'm pretty sure temperature Fahrenheit minus 32, excuse me, pen being weird, minus 32, and then divide it by 1.8. That gives you your temperature in Celsius. So I have to do that to both of those numbers, 86 minus 32, and then divide it by 1.8 on my calculator. I'm going to get a value of 30, right? And that's 30 degrees Celsius. But then I need to change that into Kelvin. So I add 273, which is simple enough here. That's just 303 Kelvin, right? So you got to do a little bit of messing around with that. You have to have Kelvin, so you just got to do what you got to do. So I can change 14 as well. 14 minus 32 divided by 1.8 gives me a negative 10 Celsius, which again, I need it to be Kelvin. I add 273 and it turns into 263 Kelvin. So those are the numbers I need. Now I can plug them into an equation. All I have to do is take that 5 liters, divide it by 303, because those two numbers go together, and that's going to be equal to X or V, whatever you want to make it, over my 263. In this case, you do whatever you need to do to solve the problem. You can use a fish method, you can cross multiply, you can just move things around to get X by itself, right? But if I solve for X, 263 times 5 divided by 303 is going to give me a 4.3399, right? Again, I'm limited to 2 sig figs because of the 5.0, so I'm going to call it 4.3 liters. When you get done with problems like this, again, you're supposed to try and make sense of it, right? Those things are directly proportional. When it's colder, the volume is supposed to shrink. I have a smaller volume. If I only have 4.3 liters of gas in my basketball, it's not going to bounce very well. So this actually should intuitively, logically make sense, your answer. You should always check your answer. Just think about, did it increase or decrease the way I expected it to? It's a really good way to check yourself every time. But that's a good example, right? Number 2 off your worksheet for Charles' law.